Hi, good afternoon. My name is Vivek Singh, and I would like to talk to you about our work on automated fake news detection. This is joint work with my colleagues Rupanjal Das Gupta, Darshan Sonagra, Karthik Raman, and Isha Ghosh. So we've heard today in the morning from our keynote speaker how fake news is really important, how it is affecting multiple things around us. It is important from a social perspective to see what's going on around us in the society. It's important from political viewpoint, and it's also very important from a security-oriented perspective. It's also growing at an exponential pace. Also, the fact that people can share information and news stories rapidly using online social networks means this is a growing problem. So we took upon this challenge onto ourselves with this SBP Grand Data Challenge, that can we automatically differentiate between valid and fake news articles. So to do this, we adopted machine learning approach, and we needed to teach a computer what is a fake news article and what is a valid news article. So to get some samples of fake news articles, what we did was we used the sample provided by the organizers. We are thankful for that. It comes from Kaggle through this plugin called BS detector, and it had different variants of BS. And some of them were labeled just as BS, some were labeled as fake, some were labeled as biased, and so on. We collectively would just call them as fake news articles for now. There were about 11,000 plus such articles for us to learn things from. We also needed some samples of valid or non-fake news articles. So we did this in two phases. The first one, we wanted to create a small data set to see, like, proof of concept. Can we actually learn and do something useful here? So what we did was, well, there's no real valid news definition. So what we can do is we can look at a couple of well-respected websites, things like NPR, New York Times, PBS, and we downloaded some articles from there. We took 100 plus articles from each, and we created this sample of about 300 plus articles, and we took an equal number of samples from this fake news sample, and we tried to do different kind of machine learning approaches and so on. We'll get into more detail about that. Then we did something similar on a much larger scale, that, hey, this seems to be a useful approach. Can we really do this at scale? So the second time we created a much larger data set. So this time we went to this PBS website again, and we tried to download as many articles as we could. We ended up with more than 23,000 articles, and we have extracted a bunch of linguistic features out of that. Both these data sets, including all the extracted features, are available at this website, and we are hoping that a broader community can engage with this kind of data and utilize this to do further research. All right. So the contributions from our team are threefold. First is the creation of two new public data sets of valid news articles. That was the first stumbling block which we faced when we wanted to compare fake and valid news articles. So we want to contribute back to the community, and hopefully somebody can start off from there. The next thing which we wanted to do was build machine learning models which can automatically predict and identify which articles are fake versus which ones are valid. So we tried different machine learning algorithms based on linguistic analysis of the content, and we have come up with multiple such models which perform above 90% accurately at trying to detect fake news. So that's the second contribution. The third contribution was that we wanted to actually dig deeper into the phenomena and actually understand which features are really important. Is it really that when people use certain words, when they use certain tone, is that predictive of an article being more likely to be fake or not? So we have identified some of those features too. All right. So I wanted to first explain this process of linguistic analysis. What we have used is this LIWC or Luke engine to automatically identify the textual content. Luke is an engine. It tries to automatically capture the linguistic, the psychological, and the sociological processes which are demonstrated in human speech or human text. We have extracted a total of 81 different features. Some of them are at a higher level. So they include things like clout, as in, is the person speaking from a position of authority or expertise. Other examples look like things like authenticity, emotional tone which is adopted, analytical thinking, and so on. So some of those are at a higher level. On the other hand, some other features are at a lower level. So they're literally word counts of things like how many words were there per sentence, the total number of words, total number of pronouns, the usage of the words like he and she and I and you and so on. But taken together, these 81 features capture something intrinsic which is going on in all the text. So we are hoping that taken together, these features help us understand some of the psychological processes, some of the linguistic processes, some of the cognitive processes that might have been going on in somebody's mind when they were typing these news articles. The overall approach which we adopt comes from machine learning, and this is a supervised learning approach, so it has two phases. First is the training phase, and then there's the testing phase. The key idea is as follows. We take a number of articles. As I mentioned, we have collected this data set of articles, and they are labeled as fake or valid. So we have some training articles to learn from. So we take these articles, we extract a bunch of linguistic features, again as I mentioned earlier, and we try to get computer to learn these labels. Now what we have are these pre-identified labels as fake and valid, as I mentioned, and we try different algorithms, included things like SVM and naive Bayes and logistic regression and so on. But taken together, we kind of built a model that when these kind of linguistic features are present, the article is more likely to be valid, for example. If some other set of features are present, maybe the article is more likely to be fake. Now comes the testing phase, right? So we see a new article. We try to derive some linguistic features. It is probably going to look something like the articles that we have seen before, perhaps not exactly the same. But we already have a model which says that when the tone is high or positive and the usage of words he and she is low, maybe it is more likely to be fake, or vice versa. So we built this process. We tested out our sample based on an 80-20 split. That's something which is commonly used. So the key idea is, yes, we derived linguistic features. We took an 80-20 split over our data. So overall, in the second round, we had about 35,000 articles. So we took 20% of that to test it out. We applied multiple machine learning algorithms, as I was just mentioning, logistic regression, support vector machine, random forest, and so on. We tried to identify the best model which came out of this. And we are reporting results from both the data sets, the one smaller one and then the larger one. So for the smaller data set, what happened was the best performing algorithm was support vector machine. Just to remind ourselves, this one was a smallish data set, so we ended up with about 800 total samples. Also, this one was balanced. We kind of took a sample of, we had valid news articles, which were 300 something, and we took an equal number of fake news articles. We put them together. The best case accuracy which we got was 87%. The F1 score was roughly the same, 0.87. And the support here is pretty small because we are dealing with a small data set. As I mentioned, we were also interested in what kind of features are associated with an article more likely to be fake or valid. What we found was if the article had higher word count, longer, it demonstrated more clout or expertise on behalf of the person writing, if it expressed positivity of tone and analytical thinking, as in the person is trying to lay out arguments logically. In that case, the article was more likely to be valid. On the other hand, and this was really surprising to us, if Luke thought an article was trying to express authenticity, and authenticity in Luke's terms is defined when somebody is trying to be upfront about things, is disclosing some personal text, trying to have a personal conversation with you, if that scored high, the article was actually more likely to be fake. So one could be that maybe it's a conscious effort on the part of the person writing that article that, hey, I'm disclosing something important to you, and that they're consciously trying to trick you into something being, into believing something that is fake. Or maybe it's a simple clue that you can't just rely on a single feature. You need like a complex signature of multiple features coming together if you want to build such predictive models. Of course, in the end, we had a smallish data set. So we said, hey, this is interesting, but let's try to test it out again over a larger data set. So what we did was we created a second data set, as I mentioned. And this time, we had much larger data set, about 35,000 total instances for us to learn and test from. And the best performing algorithm was, again, support vector machine. We had imbalanced data now. The ratios were not the same, but we also had more data to learn from. And this is probably one reason why the accuracy actually increased even further. So this time we got about 92% accuracy in terms of F1 score, which is a better measure now because we have imbalanced data. It was 0.93, and the support is now like 6,000 plus. We looked at the features which were most predictive of valid and fake news articles. And to us, this one was really interesting. the single biggest feature which was predictive of an article being more likely to be fake was the frequency of the word you. So you're literally trying to engage with the audience and using like this personal term you. The more often you use, it seems, the more likely the article is to be fake. Other clues were things like words per sentence, so maybe more complex construction, functional words, which in Luke's terms are total number of pronouns and verbs. So you is a type of pronoun. So different such words which were present, and certainty related words. Words like always and this will never happen, things like that, they were all associated with higher odds of the article being fake. And we also found, again, something surprising. The more often you would use terms like which are related to the auditory processes, things like the word listen and hear, they were more likely associated with an article being valid. So these are all very interesting initial ideas that we got out of this research, that hey, you can do something interesting here, you can start getting higher accuracy and so on, but clearly there are lots of avenues to do further more interesting and like dig deeper to understand these processes. We can do more advanced text analysis based on topic modeling, sentiment analysis, and so on. There is like basic sentiment analysis built into Luke, but clearly you can dig a whole lot deeper there. We can also utilize some image-based features. There could be a dissonance between what the image is portraying and what the text is saying, or vice versa. We could use some of the social network features associated with how this news is actually traveling over social networks, how it's going viral, and so on. So some of those features might be useful. And finally, the validation should involve somebody who's a domain expert, somebody who really understands news and media. I think that would really help us understand this phenomena from a social perspective and a professional perspective much better. So we are very excited on this journey. We are looking forward to doing more useful work. Some of those works would be along these lines. And if you would like to join us, please email me at v.singh@rutgers.edu. Thank you.